Okay, this is page 3 of the fault tolerance notes, and section 2.1 is on clock properties, and this is described in the text in section 13.4.2. And so we're going to talk about a candidate clock. We'll call it clock I, or C sub I. So clock C sub I gives time C sub I at t at real time t. So when we measure it, what's the value that we get from the clock? And so there are some properties that we need our clock to have. So first of all, we want it to be correct. We want it to tell us the right time. So correctness, and we can define this like this: the absolute value of the time that we read minus, so the time that we read minus the real time should be less than some epsilon. That's our error bound. So in other words, an absolute error bound. Okay, property 2 is that we don't want our clock to drift too much or too quickly. So we'll call this bounded drift. Should really call it the bounded drift rate. Let's make it that. So it can be stated this way: we want the rate of change of the time that we're reading from our clock to be the same as the actual change in time. And so ideally that would give us a value of 1. So the difference between that and 1 should be less than some bound rho. So in other words, clock I runs at approximately the correct rate. Property 3 is called monotonicity, and that can be phrased as the clock that we read at time t1 should be greater than the time that we read from the clock at t0, where t1 is greater than t0. And if you think about this, what this is really saying is that the clock should run forwards, it should never run backwards. So the clock runs forwards, not backwards. And there's a greater than equal sign there, and that's because you may sample the clock faster than its tick rate, so it might not have updated to the next tick if you're reading it too quickly, and that's how you could end up reading the same value twice from it. And lastly, something called chronoscopicity. I'm going to put this on the next line. So if t2 minus t1 equals t4 minus t3, so basically we're measuring two different real intervals, then what we should get is that the read time should be approximately equal. So c sub I at t2 minus c sub I at t1 should be approximately equal to c sub I at t4 minus c sub I at t3. So in other words, measurement of equal intervals should return equal values. And this all seems kind of picky and esoteric, but we're going to actually apply some of these in the next couple pages, and you'll see why they matter.